Hello everyone, my name is Taylor Bush, and today I will be presenting the dissolved uranium and arsenic concentrations in unregulated groundwater sources on the Western Navajo Nation. An overview of my presentation. First, I'll give you some background knowledge about the Navajo Nation and the mining that has occurred here. And then I will discuss some of the health effects from arsenic and uranium exposure. I will also go over the causes of arsenic and uranium in the water on the Navajo Nation and how people are getting access to this contaminated water and where it's located. Next, I will go into detail of this water contamination, like where it's occurring and possibly when it's occurring. And finally, I will discuss the remediation and exposure reduction efforts addressed in this paper. The learning objectives for students watching is that after this presentation, you'll be able to identify the locations of arsenic and uranium contamination from unregulated water sources on the Navajo Nation. Some background information for you. You can see here a map of the Navajo Nation. It is comprised of 3 different states, New Mexico, Arizona, and Utah, and the Navajo Nation itself is broken down into its different agencies. Much like a state is broken down into counties. And then those are broken down into chapters, smaller local communities, and there are chapter houses where tribal leaders and tribal members are able to engage and communicate. The 300,000 or so tribal members of the Navajo Nation, only about half of them live on the Navajo Nation reservation. And this is a relatively rural community with only a 6.33 persons per square mile density, while the national average is 345 persons per square mile. On the Navajo Nation, there are over 500 known abandoned uranium mines, and then there are even more mine features, counting in at over 1,200. Mine features include things like pits, waste piles or trenches from uranium mining. Some health effects from arsenic and uranium are listed below. Arsenic can cause things that aren't listed below, like nausea, vomiting, diarrhea, muscle weakness, cramping, and rashes. It's also widely known to cause cardiovascular disease. It can cause damage to the liver and kidney from prolonged exposure. And it's also categorized as a carcinogen for cancers like of the liver, kidney, bladder, and skin. Uranium causes chemical health effects, so it can cause kidney disease and respiratory tract damages from ingestion and inhalation. It also causes radiological effects, so the cancer risk of a person increases depending on how much uranium they're exposed to. This paper acknowledges that the small population size of the Navajo Nation, as well as the absent/ineffective policy accounts towards the lack of knowledge and understanding of how arsenic and uranium exposures are affecting the health of the Navajo Nation population. Some causes of this arsenic and uranium going into the water from these mine sites and features are chemical reactions. Arsenic can undergo reactions like desorption and dissolution, causing it to go from a non-dissolved to dissolved state. Arsenic and uranium are seen in high concentrations at uranium mine sites, so they're often spoke about together. Also, arsenic and uranium both like to be in their oxidized states, and they co-precipitate in minerals together. Acid rock drainage is a process where sulfide minerals undergo weathering and oxidizing, allowing them to dissolve, and these minerals can also contain things like arsenic and uranium. Acid mine drainage is similar, but it's when minerals are exposed to oxygen and water from mining practices that lead to an increase in the pH of the solution and an increase in dissolved metals in the solution. From there, you can have increased mobilization from the large amount of water discharge from mine sites. So now that we know kind of how some of this arsenic and uranium could possibly be mobilizing into the water, we can look at how people are getting access to this contaminated water. Most of us here in Albuquerque get our water from municipal water sources. However, 30% of the homes on the Navajo Nation lack access to municipal water supplies. Therefore, most people depend on either hauling water, which requires time, money, and transportation, or they utilize unregulated water well sources. The problem with unregulated wells is that they're just that, unregulated. They don't undergo routine water quality monitoring, appropriate water treatment, and they might not have integrity in their construction as far as materials and the depths needed to access and provide safe water. Here you can see a map of the research site, which is in the western chapters of the Navajo Nation. Each point on this map is an unregulated well that was sampled during this study. There are two main aquifers in this area, the Coconino Aquifer or C aquifer, and the Navajo Nation, the Navajo Aquifer or N aquifer. The C aquifer is rather deep, so it's hard to access for adequate water supply, and it also has high levels of salinity, making it not safe for drinking water. The N aquifer is better suited for drinking water and is easier to access. However, it's known to be depleting, and it has elevated uranium concentrations near uranium sites. Here are some results from the sampling that was done at these locations of unregulated wells. The water sampled from each well underwent induced coupled plasma mass spectrometry, or ICP-MS, which tells the metals concentration in the solution, the metals being uranium and arsenic. The highest level of arsenic and uranium were both found in the southwestern part of the sampling area. 9 of these sources exceeded the uranium maximum contaminant level, and 14 sources exceeded the arsenic maximum contaminant level, both regulated for drinking water. Note that these levels are for drinking water, but not for livestock and irrigation use. Some of these wells were labeled not safe for drinking, but people can still use them for livestock and agriculture. The correlation to the highest concentrations being near mine sites was not met. So some sites that were not near mine sites or mine features did contain elevated arsenic and uranium concentrations. Also, an important conclusion made from this data is that the highest levels of arsenic and uranium were from wells where the aquifer source was unknown. So it's important that further research is done to understand the aquifers that these elevated concentration wells are pulling from. This table talks about some of the other parameters that were monitored from these water samples that were taken. It's important to look at these conditions to help expand the story of why there could be certain concentrations of arsenic or uranium, depending on the aqueous characteristics. For instance, I previously mentioned that arsenic and uranium are more soluble in their oxidized form. So it's important to look at things like the oxidation reduction potential of the water. However, no conclusions were made in this paper from the information in this table, besides just data collection. Some of the other key data collection from this study was seasonal variability. It's important to look at how the concentrations of arsenic and uranium change depending on the time of year because of the trends in water events and evaporation. For instance, when it's drier and hotter outside, you expect more evaporation of water from water features and open water storage tanks. This evaporation leads to an increase of the concentration of arsenic and uranium in the water because you have water leaving the system, but leaving behind all these metals. The Navajo Nation receives the majority of its precipitation during the late summer months between July and August, resulting in a lot of flash flooding. These precipitation events are important for arsenic and uranium mobility and dilution. Here we can see results that the arsenic and uranium concentrations did exceed maximum contaminant levels during certain times of the year. However, it's important to note this is only for 2018. This is only for 1 year, and it can't be compared to any previous data, but it could be compared to future data. So in closing, I'd like to go over the remediation and exposure reduction efforts addressed in this paper. Community engagement and communication were vital for the success of this research. Researchers listened to community members about which unregulated wells they wanted to have tested and what they're using them for. Researchers also had to reach resolutions with tribal agencies and chapter houses to be able to take water samples from these well sites and gain access to the areas. Researchers provided maps of the well locations and their corresponding uranium and arsenic concentrations to community members for them to be better informed and educated about their potential exposures to these metals. Researchers also gave presentations at the chapter houses to answer community members and community leader questions face-to-face. While doing so, they also provided each chapter house with reports of the data collection and conclusions provided by this research in layman's terms, as well as translated in Dene, which is the language of the Navajo people. The community involvement from the design process all the way to how the results of the project were communicated was done very successfully. This data was collected and interpreted for the purpose of not only informing the academic community, but the community members using this water. Lastly, efforts toward remediation and exposure reduction efforts from this research was providing baseline data collection. There's not historical records of uranium and arsenic concentrations on the Navajo Nation prior to uranium mining. This makes researchers have to compare concentrations to present-day data points, looking at concentrations significantly far from sites and relatively close to sites or on sites, which is not as reliable to comparing historical data points. Lastly, this paper provides motivation for future research opportunities. Some research opportunities and future work that needs to be conducted just from the data collected in this paper alone are how aqueous conditions at these unregulated wells contribute to arsenic and uranium concentrations, and how seasonal variability accounts for changes in arsenic and uranium mobility. Thank you so much for your time and attention. If you have any questions about my presentation, please feel free to email me at taylorbush3@unm.edu. And here is the reference of the paper that I discussed. Thank you.